want to demo the first two examples in section 10.5. I'm going to begin with angles that are found on the circle, and the second example would be angles inside the circle. I'm going to save angles outside the circle for a later day. Let's begin with angles on the circle. Pretty straightforward. We have a line DA that is tangent to the circle at point A. We have a chord AC that it intersects with. We want to find the major arc ABC. We know it's major because it has to pass through around here, and based on this chord, I can see it's going to be greater than 180 degrees, and we're given this angle 70 degrees. So right off the bat, I'm looking at this chord and this tangent, and they intersect to form what looks like a linear pair. We know that has to add up to 180 degrees, so I can pretty confidently label this angle as 110 degrees right here. Now we're asked to find the major arc. Let's relate these two angles to the possible measure of the arcs remaining in the circle. We know that the linear pair, the supplementary angles, are 180 degrees, and we know that the entire arc measure of a circle has to be 360. If we relate 180 to 360, that's right, we would double them. So if I wanted to find the minor arc, AC, I'm just going to double 70, and that would be 140. And for my answer here, I'm going to double 110 to get the measure of the major arc, which is 220. So together you have 220 and 140, which add up to 360, and that's how you would do anything with an angle on the circle. These operate in a pretty similar way to the inscribed angles you learned about in 10.4. Let's go down and look at angles inside the circle. Now we have two chords intersecting, and we're going to find two answers here, x and y. We have two small minor arcs given, 42 and 36, and I want you to notice that neither of these chords are diameters. Neither of them intersect the center of the circle. So if they were diameters, they would be central angles. They would have the exact same measure as the arcs they formed. But for this one, we need to learn a quick new formula. Let's solve for x first. X is going to be the average of these two arcs. So the measure of this angle, x, is going to be 1/2 times the sum of 42 and 36. So that's 1/2 of 78, which is 39 degrees. Does x have a vertical angle? It does. So if it has vertical angles, does it also have a linear pair to find y? It does. Y here is going to be 141. All right. It would have an additional angle of 141 right here. However, we would need some additional information to find the exact measures of these two remaining arcs. I know that 141 is going to be the average of those two arcs, but it's hard to specify how they would balance out in the end. So from this information, you can solve for x and y, but we need a little bit more if we wanted to get the measure of these two arcs.